यार हो गया आपने ज्वाइन कर लिया मतलब ये बहुत very good morning to all. As per our routine practice, we are having today lecture of our professor Dr. Dwivedi, who is professor at Indian Institute of Legal Metrology at Ranchi. He is working as a lecturer. He worked as a lecturer during 2000 to 2006 at Ewing Christian College, Allahabad. He is PhD in science from Allahabad University. He is from BIS. He is designated as an expert from India for ISO documents related to the calibration of storage tanks. He has written international publications in the Journal of Molecular Liquids, Germany, etc. He has participated in various programs of the legal metrology, internationally participated in different meetings, in CL meetings, etc. He has a lot of experience in the field of legal metrology. He has worked not only in the field of science or the physics at college, but also in the legal methodology. He is very well involved in the technical development of the standards, which we are making as per the OML standards. So I would like to welcome Professor Dwivedi. Thank you very much, sir, joining us.
Thank you, sir. Thank you, sir.
Issue. As we are all aware, today we are going to discuss a very important topic related with how we can test a radar instrument or a speedometer, which is using the radar. Speedometer, which are used for measuring the speed of vehicles, are very important equipments for the wear and tear of the roads and to prevent the accidents. So without wasting time, I would like to request Professor Dwivedi to kindly enlighten us with his vast knowledge and experience. Over to you, sir, please.
Okay, thank you, sir. Thank you very much, sir, to give me such opportunity to discuss on our radar equipment for measuring the speed of the vehicles. Basically, today presentation is divided in three segments. First segments relating to the basics of the radar, because we must be familiar with the equipments. Second one is the technical and legal aspects of that instruments internationally, as well as we know that our government has also notified and published the rules based on this. So we must be familiar technical and legal aspects. And finally, we should also know the calibration or a verification part of that instrument. So, sir, with your kind permission, I would like to start this. Sir, is slides are visible?
Sir, very well. Please continue, please.
Okay. So, in relation to any weighing or measuring instruments, especially in the field of legal metrology, one thing is very important to know the worldwide or global traceability of that equipment. So, especially when we are talking about the radar, so international label documents are recommendation. It is based on OIML R91 edition 1990. When we see about this instrument in other fields, say ISO, and if we see as a national standard, then we find only regarding the marine radar reflectors. These are given under the Indian standards 13708 based on ISO 8729-1997. But especially for the traffic radar, still it is not there. So now that radar, based on the OIMLR 91, our government has published this white GSR 34E, and this is effective from first day of July 2025. So first, within 10 to 15 minutes, we should know about the radar. Actually, when we will go in detail, then we will find the name of that microwave Doppler radar equipment. Means itself in name, three things are there. Microwave, second one is Doppler, and third one is radar. So all three terms we will see, and we will see the joint effect of that instrument to measure the speed or the range of that target or object. So let us see actually the journey of the radar beginning from 1904. 1904, first time Halsmeyer, who has first used this as a device to help to avoid the collision of the ships in a fog in a very beginning, and especially in a professional way, the radars came in picture in World War II. In India especially, India Meteorological Department IMND has been operating radars since 1949. The full evaluation of the radar we can see in three phases. Phase 1, 1950s, phase 2, year 2000, and the current phase is under the phase 3. Actually, in phase 1, especially if we are talking about our country, basically the radars are imported and installed in cities. In phase 2, little bit advancement and the radars are used for storm warning, X-band radar, cyclone warning, radars with more power and range. Now the phase 3, advanced technology. And currently, if we see, the advanced radars are fitted also in fighter jets and for other purpose, named as AESA. If we see, active electronically scanned array. See here, such kind of the radars are there. Those are very much powerful, having the bi-directional approach to detect the things. And current era is phase 3 is active electronically scanned array, AESA radar. But we have to focus here traffic radar. When we are talking about the traffic radar, really this is a very important, not only for the highways, but also in urban areas, helping law enforcement agencies control speeding and reduce accidents. Traffic radar technology has evolved significantly, moving beyond simple speed detection to offer advanced features that contribute to better traffic management and safety. This equipment helps the authority responsible for that purpose to manage the traffic and also the human being safety. This radar is equipped with precision. It can detect the particular speed of the vehicle, and if it is integrated with the camera and other facility, it can also record the data, license plate recognition, ALPR, so that once ALPR is recognized, then we have the details of the license and details of the particular vehicles. Now, radar actually, this is a acronym of radar, means detection and ranging in a technology that basically uses the radio waves. But here we have to study on microwaves Doppler radar. But basically the concept was radar came from the radio waves. If we see electromagnetic waves, because microwaves are the electromagnetic waves, and if we see the spectrum of that, based on the frequency and wavelength, longer wavelength and shorter wavelength. Here if we see radio waves, microwaves, infrared, ultraviolet, X-ray and gamma. But microwaves are most suitable for trophic radar because it is climatic friendly. It has the ability to penetrate the foggy, cloudy season, and having the specific nature of the frequency and wavelength, which make the microwave most suitable for radar equipment. So if we see the nature of the waves, microwaves, depending upon the frequency and wavelength, we can see a projection of that. Because after this discussion, I will continue regarding this because we have to go through the Doppler shift, how the frequency shifted. So if you see frequency changes, the wavelength changes, and finally this equipment based on the frequency change. So as I'm saying, why the microwaves are preferred for this? Microwaves can penetrate various material, including clouds, fog, rain, and allowing radar system to function effectively. High frequency nature of microwaves allows for higher resolution imaging, enabling radar system. Because of that reason, traffic radar microwaves are most suitable. Now, another word is Doppler, because the complete name is microwave Doppler equipment. So what is the use of the Doppler here? Doppler effect in radar phenomena means frequency of radar signal changes when it's reflected off a moving target. So change in frequency, for example, transmitter is there working at a high power, and whatever the incident waves after reflection, the frequency is changed, whether it will increase or it will decrease depending upon the motion of the target, whether target approaching to the transmitter or going away from the transmitter. So there is a change in frequency. That change in frequency is known as the Doppler shift, and this will work as an input quantity. So now for the radar equipment, which one is the input quantity? And based on that, we are getting the result or output. So here input quantity is change in frequency of what? Waves. Two waves are there. One is transmitted wave and another is reflected wave. So transmitted wave and reflected wave, when device measures, then it measures the change in frequency. So that change in frequency is called the Doppler shift. Now, with the help of that frequency, we will correlate with the velocity of the target or vehicle. So if target is approaching to the radar, reflected signal frequency will be higher, and this is called the positive Doppler shift. If the target is moving away from the radar, then frequency will be lower, and this will be called a negative Doppler shift. If the target is stationary relative to the radar, for example, target is not moving, it is in a rest condition. So whatever the frequency of the incident beam, the same frequency will be the reflected beam, and there is no Doppler shift, means there is no frequency change. That means there is no Doppler effect, and we can't measure this. So especially traffic radar is meant for the moving vehicle. Now Doppler shift, we can establish a relation FD. This is the Doppler shift frequency. This is equal to twice of F naught velocity by C. F naught is the frequency of the transmitted wave. V is the velocity of the target, either approaching or going away. And theta is the angle of incidence. If beam is parallel to the target, then theta is 0. and cos 0 is equal to 1. Finally, we will get twice F naught V by C. And we can replace the C, means velocity of light, because the velocity of light and velocity of electromagnetic waves both are same. So we can replace the C in terms of the wavelength. And finally, equation becomes twice V cos theta lambda naught. So here we can see Fd is the Doppler frequency, V is the relative velocity, and F naught is the frequency of the transmitted radar, and velocity of the light, we know that 3 into 10 to the power 8 meter per second. So when target is moving towards the radar, then how the angle, incidence angle, theta will be between 0 to 90 degree. And frequency will increase by amount of Doppler shift. Conversely, when target is moving away from the radar, the angle theta will be between 19 to 180 degree, and frequency will decrease by amount of Doppler shift. When velocity is perpendicular to the radar line, that means theta is 90 and cos 90 is equal to 0. So there is no change in frequency. Now, one thing I would like to discuss, traffic radar. Broadly, we can divide the radar in two sections regarding the measurement of the speed and range of the object. One is called CW radar. CW means continuous wave radar, and our traffic radar is one kind of the CW radar, continuous wave radar. This is meant for detection of the target. CW radar is used to find the velocity of the moving target, and it can't measure the range. Very important line, continuous wave radar, it measures the velocity of the movement, but it can't measure the range. So if you see here, radar system, there is a transmitted antenna. Now the transmitting wave is frequency Ft. When it incidents on a moving target, because target is moving towards the antenna, so the change in frequency is Ft plus Fd. Now, if we see block diagram of CW, so here if we can see transmitter, transmitted the wave, after reflection, we get the reflected wave, that goes to the mixer. Two signals are there. One is change frequency and another is the leakage signal of the transmitter. Then to identify the FD, because this signal is very poor, so that one is amplified by using the beat frequency amplifier, and finally we are able to calculate the FD for display. Here mixers are two types, homodyne mixer and heterodyne mixer. Homodyne mixers are used for two signals having close frequency, and heterodyne mixers are used two signals having the different frequencies in a good amount. Now if we see the spectrum, then you see a very high frequency band, L band, S band, C band, X band, Ku band, K band, and Ka band. Maybe in field, if you see in radar, it is written Ka band, means Ka radar. Then you may think, okay, microwave, but what is a Ka? What is a K? What is a Ku? So if you see from where these names came, Ka, Ku, and Kb, we can see from here, we wondered how these band names come from. Actually, initially from British engineers, these names are given. So L band, S band, C band, X band, Ka, Ku, and K band. Nowadays, Ka and Ku bands are mostly seen. So we should know what are Ka and Ku and how these names came. Earlier, radar used for search purpose having the wavelength 23 centimeter. Later changed 22. That's are called L band. L stands for long band. Long means having the large wavelength. After that, when the wavelength is reduces from 23 to 10 centimeter, then comparatively it is shorter. So it is called the S band, means short band. So when we are talking L band, means we are talking about the wavelength 22 centimeter. And when we are talking S band, means 10 centimeter, and S stands for short wave band. Later radar with wavelength 3 centimeter. Now the wavelength is reduces continuously. So wavelength of 3 centimeter, that one is called the cuirassier, means X band radar. These X band radars are suitable for the fire, if anywhere is fire, to give the warning regarding this. Now the combination of X band and S band, further experiment, combination of X and S, and wavelength about 5 centimeter. So that is called the C band. C means combination of X and S. When these bands are established by the British engineers, then the work is also done by the Germans, and they also think on that in development of the radars. They have developed the wavelength 1.5 centimeter based radar, and that's radar are called K-band radar, crudes. But unfortunately, these waves are absorbed by the water vapor and others, so are not so longer used. In order to avoid this problem, they have further worked on that, and they have made wavelength just above to this, and that one is called KU band. U means under. U means under. That means frequency is more than that, but wavelength is under to the K. Further, they have worked and developed the K band. That is, K stands from here above band, means one is lower and another is above to the K, named as KA and KU. So this is about the basics of the radar. Now I am coming on the points. 1 second, excuse me. Now, based on the general rule about the radars or OIML recommendations, so entire contents are divided into 7 parts. One is scope, another is rules of correct operation, third one is construction, operation of the instrument, protection against tampering, identification of equipment, model approval tests, and in detail the tests are prescribed under Annexure A. And for additional information about the testing procedure, I have added in my presentation, but it is not under the general rule. Because sometimes if you see the general rule, then regarding the testing procedure, very widened concept is given. Everywhere you will not get that the things are verified or calibrated by using the working standards or by using the secondary standards like that. Maybe somewhere, but somewhere is very widened. For example, you see non-automatic weighing instrument. You see automatic railway bridge. You see other weighing instruments. You see other measuring instruments. Common line is there. The standards must have accuracy minimum 3 times of that instrument. Accuracy wise, 3 times more accurate standards can be used for the testing. So 3 times more. See, if any standard, traceable standard that have the accuracy 3 times almost more than that can be used as a standard. In the same way, if you see the testing procedure of the weight or balances, you will not find, because procedure and principles that must be traceable, international traceable, and the format can be made as per the laboratory requirements. Especially if we see the radar system here, it is little bit different to others in point of view of the OIML recommendations. Here you will not find terminology related to the radar. No terminology is given there. Here you will not find especially the testing during the verification or during the inspection. So we should not confuse with others. What concept is given there, we have to see. So I will come one by one. If we see the scope is simple to measure the speed of the vehicle, and radar must confirm the requisite informations given under the general rules. Second one is rule of correct operation. It is started directly from here. This point indicates the maximum inputs has to be provided by the manufacturer as in the form of the handbook or the instruction sheet, and based on that the concerned department laboratory shall execute the test whether it complies or not. So when we are talking about the rules of correct operation, then we can see radar shall be installed and used in accordance with the instructions approved with the instrument at the time of model approval. So the manufacturer will submit all the details, just like in other cases. Government and recognized laboratory execute all the tests, perform all the tests, and if satisfied, then that manual or handbook or instruction sheet will be called as an approved sheet, and it becomes one kind of the documents. Now, another thing to work properly, certainty of vehicle identification. We have listened the name uncertainty, but the here word is used certainty. Means if number of vehicles are moving or crossing to each other, then radar must recognize the speed of particular vehicle. There should no confusion. Okay, 2 or 3 vehicles are moving. So, for example, we have to find out the speed of X, but it is showing the speed of Y vehicle or Z vehicle. No, that radar must be certain and must comply the certainty. There is also a concept of aiming device. Radar may be equipped with aiming device. Aiming device, nothing simple a device which can control the incident angle or beam. Actually, this is a best observation or measurement if the target is parallel to the incident beam. Means theta is 0 degree. But ideally, if we can fix a radar in a particular position, and if we make a road map in such a way that when the vehicle will pass and comes under the view of radar, then always in a parallel position of the beam. But it is not practically possible everywhere, because radar may be fitted on a patrolling police car, so that can move. So radar may equipped with aiming device. What is the work of that? To ensure that the error of relative error of measurement due to misalignment shall not greater than plus minus 0.5%. Maybe the beam is not aligned properly, misaligned, so that is only allowed plus minus 0.5%. And if radar is fitted in such a way that all the time the projection of the moving vehicle comes parallel to the transmitted beam, then there is no need of the aiming device. So aiming device is provisional, depends upon the requirement, so that the beam can be controlled. Now, another one is radiation model of antenna. The approval of given angle of incidence at the time of the model approval, it will be given कि angle of incidence allowed from here to here, and this value is given 15 degree to 30 degree angle of incidence if beam is not parallel. If beam is parallel, no issue. Parallel means what? If moving vehicle is coming directly towards the transmitter, so incident ray and reflected ray both will be parallel and angle becomes theta. No issue. But if it is not parallel, there is a requirement that we have to set, and we have to measure the speed of the vehicle by fitting the radar on patrolling car or in any means. Then the angle of incidence is allowed 15 degree to 30 degree. And no measurement shall be possible by that radar parts of the antenna lobes where an incorrect angle of incidence may result relative measurement error greater than plus minus 2%. Please listen. Here the word again and again coming, relative measurement error. We should not confuse. One word is there, MPE, maximum permissible error. And another word is there, relative measurement error. Relative measurement error means what? Absolute error we have to calculate. Absolute error means what? True value and the measured value. And whatever the error allowed on that. So if the relative error is plus minus 2% up to that, and if greater than that, then the radar will not measure the speed of the vehicle. Recording devices, maybe radar has equipped with the recording devices, then it will record the date, time, and all the measurement data. And if the recording device is not there, then the indication of the radar will indicate the value, so that that values alternatively can be noted or stored by other means. Now then, automatic and autonomous radar concept is also there. Automatic and autonomous, what is the basic concept? Sometimes what happen, radar designed in such a way that cannot be continuously verified by an officer. It is not possible to verify by an officer if it is designed. Then it shall ensure near to certainty level of confidence, and that level of confidence is 99.8%. 99.8% level of confidence. And how it will be made means by self-test or by self-checking, or there is a provision that you can press the switch, then automatically radar check itself. So all those facility will be there if it is not possible by the officer to verify very frequent to this. Overall function of test device. Radars, very important this. Overall function test device. The radar shall incorporate some means of simulating a measurement that is independent of the measuring circuits. Means what? Radar itself a device, and that must equipped with separately any standards. By using that standard, we can check time to time to this. Just like we see na, vernier calipers, screw gauge. So there you see slip gauges are there, standards. So we can check, okay, vernier is working properly or not. So same thing, along with the radar, there must be a provision which is separate to the device and can be used to test the radar. Just like I will discuss in testing part, for example, calibrated tuning forks are there. Calibrated tuning forks. Then calibrated tuning forks will be there, and we can check the performance of the radar by using the calibrated tuning forks, because tuning forks are calibrated with the speed. For example, tuning fork speed is 55 km/h. And I will discuss the testing process. Then radar should display the 55 km/h if we bring the tuning fork after sticking on a hard surface near the transmitter. So this provision is given there. Under the construction of the radar, indications and speed range, there will be indicators and speed range. Up to what speed range it can measure. Just like we are knowing in a weighing instrument, automatic weighing instruments like railway bridge, like automatic instruments for weighing vehicle in motion. Everywhere the speed concept is given: maximum operating speed, minimum operating speed, and sight speed. In the same way, here it is also given speed range 30 km to 150 km. And the radar design will be in such a way that solidly built, because it may be in a exposed portion of the area. So it has to be tolerate the climatic condition, storm, rainy season, like that. So mechanical strength shall be checked. Now resistance to extreme climate. We know that climatic condition, cold, summer, so there is change in temperature. So whether it is suitable for that temperature or not, so that is given -25 degree to 70 degrees centigrade. So all those things under the construction part, it was seen. Now reliability of electronic and logical components, because radar, it is based on electromagnetic waves, there is a microwave sections and others. So electronic components and logic components are used. So that components must be reliable. Reaction to disturbance. If any disturbance, whether influence quantity due to the influence quantity disturbance or influence factor or others, so there must be we have to check how much impact of the disturbance on the result of the radar, like due to the power line variation, electrical burst, external electromagnetic fields, like that. Protection against electronic failure. There must also be, these are very common thing. Every device is protected due to if any high voltage or anything, then you know that fuse is there. So in the same concept, if due to any high voltage or any others, then it must be equipped with the protection device which is against the electronic failure. Now next, fourth one is operation of the instrument. This is given in our general rule. Operation of the instrument, how the theory of the operation of equipment is given in the instruction sheet. An explanation of general operating, mode of operation, information about the peripheral, all the information will be given under the handbook or instruction sheet approved during the model approval. Now, provision is also given regarding the protection against the tampering. All parts of the instrument which on tampering may be led to error in measurement. If anyone is doing tampering, then it is facilitated with error show on a display. Metrologically unreliable operations shall be sealed and protected. So these are very common, just like other instruments. Identification of the equipment, it is given. How we can identify? Very simple, the name of and address of the manufacturer, type, indication, serial number, model approval number, all those are the part of the identification of the instrument. Next one is model approval, because maximum thing is given under the model approval. This instrument is designed especially for the test during the model approval. If we see the model approval part, we can divide into 4 parts. One is metallurgical test in the laboratory. Another is test of effects of influence factor. Third one is metallurgical field test. And fourth one is conformity to the approval model. So let us see details about the model approval test. Prior to start the test, everywhere it is given test conditions. Sometimes it is also called reference conditions. So test conditions are given here. If we see ambient temperature, prior to start the test, what are the ranges of the reference conditions? So first of all, ambient temperature minus 20 degree to 60 degree. Ambient humidity 60%. Power voltage nominal minus 10% to 20%. Frequency nominal plus minus 3%. So these are the reference conditions or test conditions. If you see overall view of the reference conditions, then we will find everywhere in all the model approval test, the reference conditions are given, and keeping in view the tests are performed within that varied reference conditions from lower range to the upper range, whether it is related to the temperature, whether it is related to the humidity, whether it is related to the frequency or other which is applicable for that instrument. Radar shall be tested during the model approval at 20 degrees centigrade and minimum and maximum applicable temperature. Similarly, humidity, and for each test, factors involved relating to the humidity, temperature and others. Variation throughout the whole defined range from lower to higher. It shall not induce a change of indication, whatever we will get on indication, greater than 50% of the module of MPE for microwave section testing or lower frequency section testing. So whatever we will perform the test, and when we varied the conditions from lower to higher, then change in results shall not be more than the 50% of the MPE. Testing of microwave section during the model approval. Radiation pattern and power limitations, it is tested. Radiation pattern, when we are talking, means we are talking about the incidence angle with respect to that. So within 15 to 30 degree, we will change the radar position 15 to 30, and during the test we have to observe whether the results are the within MPE or not, and relative measurement errors not greater than plus minus 2%. Under the microwave section, aiming device is also tested if it is equipped with the aiming device. So for aiming device, when we are checking, then we see कि due to the misalignment of the beam, the relative error shall not more than the plus minus 0.5%. Testing of the low frequency section. This is important, where we will use the Doppler shift. Testing of the low frequency section. VD means velocity of the vehicle is equal to 0.5 into FD into delta L divided by cos alpha. where lambda is what? Emitted wavelength by the antenna. Alpha is the average effective angle of incidence. And FD is the Doppler shift, change in frequency. So by putting because FD is known, lambda is known, alpha is known, we can calculate the VD. If we see the example to apply this, for example, a police radar gun emits microwave of frequency 10.525 gigahertz. A car is moving directly towards the radar gun. Reflected signal is received at frequency of this. Light speed is given. We have to calculate the speed of car. So first of all, we will calculate change in frequency. This is original frequency, emitted wave frequency. This is reflected. This is called change in frequency. This change in frequency is called the Doppler shift. By putting this formula, because velocity of light is known, F naught is known, C is known, we can calculate the velocity of the car. Now, one thing we have to remember, all errors are indication related to the VD. Sometimes we confuse that this is MP plus minus 1% and above 100 kilometer 1%. This MP is for error of indication regarding the velocity of the vehicle measurement. When you are measuring the vehicle, then error of indication we have to see. It should be less than plus minus 1 kilometer per hour up to 100 kilometer speed. If speed is more than 100 kilometer, then it becomes 1% of that. Similarly, these tests are performed during the model approval. Now, other test, if major test is due to the influence factor. Influence factor test, this is common, very common for all weighing and measuring instruments. So we should know what is this actually. We know that influence quantity, for example, in any lab, you have to measure the mass. So your measurement quantity is mass, but in that room, the presence of the other physical quantities like temperature is there, like pressure is there, like humidity is there. But we have to not measure temperature, pressure and humidity. Basic our objective is to measure the mass, but these quantities are present there. So these quantities are called influence quantity. They may influence our result. So if the extent of influence of these quantities are within the prescribed limit, means they are influencing the result, but the impact is within the limit, then these influence quantities are called influence factor. But if the impact of influence quantity is beyond the limit as specified, then these are called the disturbance. Then how much they are disturbing our result? Then we have to perform the test at the time of the model approval. Now another test is given, metrological field test. This test is related to the field test. So sometimes we confuse, okay, what test we have to perform in the field. So test shall be performed after the test of effect of influence factors and disturbance. This is also part of the model approval testing. This is not part just like other instrument ki field test means this is talking about the verification or inspection by the enforcement authority. This is also the part of model approval testing. When the test regarding the influence factors or disturbance are completed, then that device is fitted under actual operation condition. That is called the field test. And when we perform and we are getting the result from device, then the average error of all results, for example, we have taken 5 observations. So what is the average error? Average error of all result shall be within plus minus 1 kilometer per hour. This is talking about the average result. 1 MP I have discussed that for each indication below the 100 kilometer per hour speed, it is given plus minus 1 kilometer per hour, and beyond that 1%. But here it is talking about the average error. This is plus minus 1 kilometer per hour. During the model approval, 500 measurements shall be made. 500. Set of measurement is 500. And when we will take 500 measurement, then the positive error shall not be more than not more than plus 3 kilometer per hour. Positive error. And if it is above 100 kilometer per hour, then plus 3% when we are taking the 500 measurements during the model approval. Now, regarding the standards, sometimes the discussion is made that now new equipments are published and standards are not prescribed properly. So we should think here, standards, very common in every national or international document, one line is given that the standards having the better uncertainty. How much? 1/3 of that radar. Better uncertainty, 1/3 of that radar. If that device is available, we can use as a standard. So the same concept in mass also, in volume also, in length measurement also, your standards must be more accurate. How many times? 3 times. So the same thing is also saying here, if we are using any reference to verify the radar, so what is the condition of that reference? Better than 1/3 of that radar under test, means 99.8% of its result, and error must be within plus minus 1 kilometer per hour. Then we can use as a reference. Conformity to approved model, last. What should be the conformity? Once manufacturer gets the model approval certificate based on the handbook or instruction sheet submitted by him, based on the principle, drawing, or whatever sketch is required, and once get the model approval, then the device or equipment must work within that terms and conditions based on that principles and others. If any changes is there, then has to be informed that such kind of the principle or change is made on that equipment, then it must be informed to the model approval issuing authority. Now, in addition, prior to that, whatever the tests are prescribed in model approval, it is given in Annexure A. Broadly, it is divided in 3 parts, only 3 parts. One is mechanical strength test. Mechanical strength test. During the model approval, mechanical shock, radar shall be tilted about bottom edge, and after test check in accordance, when we will make all the conditions are created by tilting, by giving the shock, then we will see, okay, now the results are within MP or not. Similarly, we will change the climatic conditions, temperature, pressure and others, then we'll further check whether its performance is within MP or not. Then test of reliability of electronic and logic components by varying the voltage, by varying the magnetic and electric field, and it was seen. These are the common setup and mostly applied in all equipments by the recognized laboratory to perform these tests. Only the difference is that the reference condition range is different for different instrument, but the process and requirements are same. Now, in addition, in the last session of this presentation, I would like to discuss regarding the testing part, which may help to the enforcing authority in future if the such kind of the provision may be included in this, that how the enforcing authority can also cross check or there is need or not. This is the matter of the competent authority regarding this. But whatever is used in other country, in UK, if we see volume 114 number 3 May to June 2009 Journal of Research of National Institute of Standards and Technology, they are using the method to calibrate the radar. TTR, down the road radar, radio detection and ranging in United States. What are the basic components of that radar? Transceiver, mixer, processing component, display, human interface component, etc. They have seen, they checked whatever I am discussing about the aiming device. So you see here, patrolling vehicle is there and van is there to which we have to measure the speed. So we are seeing there radial speed because angle is theta. If it was in the same line, then theta becomes 0 and it becomes parallel, and there is no need of the aiming device of such cases. But here theta is not 0, so the limit of theta is 15 to 30 degree. Now in that paper in journals it is given tuning forks that can be used, pre-calibrated tuning forks, a speed simulator based on amplitude modulation, vehicle's speedometer, because in vehicle speedometer is fitted, fifth wheel, just like a thin wheel, and tire similar in appearance to a unicycle without a seat, just like we are testing the taximeter. So I have make a flow chart like testing flow chart. You can see very easy. I have divided the position of the radar in two parts. One is stationary mode and another is moving mode. This is a testing procedure by using the tuning forks. This is also taken from PB Electronics West Peaceful Code USA document 40165. Place the radar stationary. When we are talking this testing, we have to place the radar in a stationary mode. Then what we will do next? Place the range control in maximum position. Whatever the radar range, we have to set at a maximum position. Antenna in the transmit mode. We have to hold the switch to make the antenna in a transmit mode. Putting the radar in a run. Now we have to start the radar. After that, what we will do? We will take a tuning fork. That tuning fork is pre-calibrated with speed. So strike the lower speed fork. When I am saying lower speed fork means larger tuning fork. If tuning fork edges are larger, that means speed is lower. So first we have to start the calibration from lower to higher. So we will take one tuning fork and strike lightly on a hard non-metallic surface and hold the tuning fork approximately 1 inch front of antenna. Then we will see the antenna will receive the signals and it will show the speed of the tuning fork. So if tuning fork is showing 55 km per hour and we are getting the display 55 km per hour plus or minus whatever within the range, then we can say, okay, radar is almost working properly and meets the requirement. Now, for more accuracy, we will take another tuning fork. Just like we are taking the observation more than 1, 2, 3, 4 observation for statistical requirement. So same way, you can use more than one tuning forks for stationary mode. So first tuning fork, we will note down the reading. Second tuning fork, comparatively higher speed. Then third tuning fork, higher speed. We will repeat the process. Now this is okay for the radar in a rest condition. But now next is most important, moving condition. Now this is, please say. If radar is in moving condition, then further there are two things. One is whether they are approaching to each other, and another is whether they are going to away to each other. So place the radar in moving condition. You see, these are tuning forks. Speed is written here. They are pre-calibrated. Now, two tuning forks are minimum required for moving radar. Radar in rest, okay, one tuning fork, but for more accuracy, we may have more than one. But moving radar cannot be done verified by using single tuning fork, two tuning forks, because there is this is in a motion, whether it is approaching or going away. How we have to do, please see. First of all, opposite direction mode. If vehicle is going away from the radar, strike the both forks. This is one fork, this is another. Strike the both forks. Place slower, larger fork in front of the antenna. This is larger, so its speed is less. So first we have to place this tuning fork against the antenna. Now then another tuning fork, faster, we have to place in front of the antenna. Radar should read the speed difference. This radar will what? Because this is moving opposite direction. So what will be the speed difference of that? So one tuning fork, then another tuning fork. We have to keep the position perpendicular to each other to get more accuracy. So at a time, both tuning forks are made close to the antenna, and if they are moving in opposite direction, it will measure the difference. Now, if they are in the same line, same lane mode, so earlier we have taken slower, now we have to take faster fork, then slower. Now you will get the result, sum of the speed, because they are moving in the same lane. So they are showing the sum of the speed. So here you see petrol speed, opposite direction, 30, because it is in a UK style, so mile per hour, but we will take kilometer per hour. 25. Now in the same lane, it gives the sum of that 55 and 85. Now the same thing, one video is available in YouTube. You can see how they are putting this. Last on that, please.
You want to run the video?
Sorry,
You don't want to run the video?
the video is not running.
Yes, yes, please.
No, is running or not?
No, it is not running.
But here it is showing.
So actually, when you will do this, you have to again unshare and then again share the video in place of this.
Okay,
Then
okay,
only it will come.
okay, okay, okay.
Changed in same line, same direction traffic. Faster, forward, speed should be the fastest move. Target speed should be some.
Now, sir, is running?
Sir, what you have to do, you have to unshare the PPT and then share the video.
Okay, sir.
Atul ji,
हुआ सर?
not yet. What did you just, sir, you share it to me, PPT as well as the video. Immediately WhatsApp it to me. I will share from my side.
Not sharing like that. Okay, I think now it will share.
Not yet.
No, now I'm going to share.
Not shared yet, sir.
सर एक सेकंड सर. Is share sir?
No,
Is
sir,
share sir?
not yet. Not yet.
Okay sir. So actually whatever in the video I have already discussed, so no issue.
Okay. No, if you wish to, if you can WhatsApp it to me, I will share it from my side.
Okay.
We can show it right now if you share it with me.
Okay, just I check it is.
Because after I would like to request Atul ji, am I audible? RSL Ahmedabad, am I audible?
Yes, sir.
Kindly make all other participants the panelist.
Okay, sir. Okay, sir.
Now sir is share?
Yes, yes, yes. But there is no voice.
No need voice sir. Only demo is. Now starting sir from beginning.
Okay, very good, very good, very good.
Okay, please.
Killing. Change to same lane or same direction traffic. This time, faster, forward, first. Control speed should be the faster forward. The target speed should be the
Okay, sir. Thank you.
Thank you very much, sir. Thank you very much. I would like to thank our Professor Dr. D.K. Dikshit Dwivedi from ILM Ranchi and all the participants. I would like to request all the participants to kindly switch on their video. Sir, I would like to request you to kindly share me this PPT as well as this video, which we will upload on our website.
Okay,
And the
sir.
participants will be benefited from this. It is a wonderful exercise which you have shown, and the experiment was very simple, very easy. With this, can we close, Atulji?
Yes, sir. We can close, sir.
Thank you very much. Thank you. All the participants, thank you very much. We will meet next week with the next topic. Thank you. Thank you, Professor Divedi
Thank you,
sir.
sir.
Thank you.
Thank you,
Namaskar.
sir.
Thank you.